Hopefully you're having a great summer and you've taken a brief moment out of your time to do a little bit of your over the summer chemistry review. For most of you, this is going to be the definition of a review. It's something that you've already seen, you've probably done a lot of, but there might be some new things. So since this is AP Chemistry, it would probably help if I define what chemistry is. Chemistry is the study of matter and energy and the changes they undergo. Matter is anything that takes up space, has mass, and exerts an inertia, which simply means that if it's in motion, it's going to stay in motion. If it's at rest, it's going to stay at rest. So everything from the largest star to the smallest insignificant atom to the things that make up those atoms is all made of matter. Everything you come in contact with on a daily basis is matter, with one exception, and that is light. Light is not made up of matter because light does not have a mass, nor does it take up space. Matter is comprised of only about 100 elements or so in various combinations. One of these with 6 of those, 2 of these with 1 of those, and one of the most common matter that we come in contact with, at least here on Earth, is water. So let's talk about water. Water, in case you didn't know, is H2O. That means it has 2 hydrogen atoms attached to 1 oxygen atom, and that together, that makes water. Obviously, since water has a mass, it has a particular weight to it, and it has a volume, it takes up a certain amount of space, it's matter, and therefore it matters. You can pass an electric current through it, and it will separate into its constituent elements, because these, oxygen and hydrogen, are elements. They are the smallest part of matter that retain their individual properties. Water itself is what we call a compound, and we'll have whole videos about that later. For right now, the basic concept you need to know is that you can pass an electric current through water and separate it into the elements that make up that matter. Chemistry is the study of how this reaction would occur. Because we have one particular type of matter, a compound known as water, that's undergoing some sort of change into a different compound, oxygen and hydrogen gas. Oxygen and hydrogen are a gas, water is a liquid at room temperature. Oxygen and hydrogen are combustible. You can't necessarily make water explode at room temperature. The fact that you have matter changing into something else is what we call a chemical reaction. Some chemical reactions are reversible. For example, if I pass an electrical current through water, I break it into oxygen and hydrogen gas. But if I ignite them with a spark, I can turn them back into water. So since chemistry is the study of matter and energy and changes they undergo, or the changes between them, and everything is made of matter, or most things are made of matter, and energy is pretty much everything else that's not matter, you can understand that chemistry is central to the understanding of all other sciences. Because if you can understand the chemistry behind it, then you understand the concepts that are at work in the other cases. So chemistry is going to help you in all of your classes, most likely. From this AP class, you'll probably become a better problem solver. And the brain is one of the most powerful muscles in the body, even though it's not necessarily a muscle. But it, like all muscles, has to be trained, and you'll get that training in this course. If you understand chemistry, you'll be probably a safer person out in the real world. And in general, it's because if you had me for baby chem, I told you had to take it. Which I'm telling you right now, I kind of lied to you a little. But we'll get on to me as a liar later. Let's move on through some chemistry. Since chemistry is the central science, it would probably help if we talked a little bit about the scientific method. Now I know you probably run through this in every science class you've had since elementary school. So I'm going to go through it rather quickly. The scientific method always begins with you observing some sort of phenomenon. I see that by adding Mentos to Diet Coke, it explodes. I observe that phenomenon. Based upon that observation, I form a hypothesis, which is an informed prediction based upon the observation that I just had. I hate how in middle school they say it's an educated guess, because there's not a lot of guessing to it. You have to observe something, and then based upon that observation, predict if I change just one thing, is that going to have an effect on this phenomenon. So for example, a hypothesis based off of, say, the Mentos and Diet Coke reaction would be, well, if I double the Mentos in the Diet Coke, will that double the height of the geyser? I'm basing my prediction upon the observation that I had. Next, you carry out an experiment to test out that hypothesis. So I would have a control in which I only add one Mentos. That's the baseline, and I compare everything against that. Then I would have multiple trials. One trial in which I have 2 Mentos, then 3, then 4. And in each one of those trials, I would have multiples of that trial. After doing the experiment, I can adjust some of the variables, or I can, sorry, not adjust some of the variables. I can analyze the data from that, and based on that data, I now have new observations that I could make a hypothesis off of and then test. And if I do that enough times, if I experiment enough times that I start to observe a continuous pattern, I can develop a model or theory. And theories are hypotheses that are put together or crammed together into one little sentence that explain why a particular thing happens. So if I observe the Diet Coke and Mentos reaction over and over and over again, and I have collected enough data, and I find out that cinnamon Mentos does not make the geyser as high, well, that would go into my theory that cinnamon Mentos does not cause the geyser to go as high because it's the mint in the Mentos that causes it to go to explode, or whatever the theory happens to be. That's not actually how the Mentos thing works. If you want to know how it works, Google it. Theories and models are constantly being changed. Ooh, and that's a clock, and that's now I'm having tough problems. Okay, hold on. So theories and models can be changed. For example, it used to be a theory that the world was flat, and then Columbus came along and said, no, it's not. It used to be a theory that the world went around, that the sun went around the Earth, and Galileo said no, or Copernicus, sorry, said no, it's not. So theories are often changed and modified as experiments prove or disprove parts of them. Now there's a difference between a theory and a law, like scientific theory versus scientific law. A scientific theory explains why a particular thing happens, whereas a scientific law explains what happens. And one of the most integral laws of chemistry is the law of conservation of mass, where no matter what you start with, you have to end with the same amount, or the same amount of matter. No matter what changes, the mass of your reactants, the things that are reacting, has to equal the mass of the products, what you produce. And since matter and energy are related, Einstein's most famous equation, energy equals mass times the speed of light squared, since they're related, there's also a law of conservation of energy, where energy cannot be created or destroyed. It can only change forms. This law of conservation of energy, as well as the law of conservation of mass, is the reason why we have to have balanced chemical reactions. Remember that from baby chem, balance the reaction? Well, the reason you're doing it is to appease the law of conservation of mass. So there you go. Your first AP chemistry video, and I don't think I even taught you anything that new. Stay tuned for more.